All right, I'm going to review how to do a couple of these circle sector problems. So in the first one, we have a circle X with a radius mx of 3. And the central angle measures 25 degrees, so maybe it's this big. This is 25 degrees. And the question is, how long is the arc length my? It's mxy. And you're supposed to write it as a reduced fraction using pi. So to do this, I'm going to first figure out the circumference, which is simply the diameter times pi, so that's 6 pi. And then this fraction of this is just 25 out of 360. So the arc length of the measure, no, not the measure, the length of my is going to be 25 over 360. That's the fraction of the circle times 6 pi. So this is basically it, except there's a lot of reduction that has to happen here. So 25 over 3, oh, there's an easy thing to cancel out. 6 and 360, those are both 6's, so that's 1 and 60. And then I've got 5's in both of these. So I'm just going to rewrite this so it's a little easier. 25, 60 times pi is, I can cancel 5, and 5 there is 12. And I think that's it. So this is going to be 5/12, if we're going to write it in here, space pi. And if you were writing it by hand, it would be probably 5/12 pi, or you could do 5 pi over 12 would be the same thing. In the next one, you have a circle with radius QC. That's 2. I'm going to draw that a little smaller there. So Q is the center, and C. And we've got a little tiny 10-degree arc here. And in this case, we want to know what the area of that sector. So we want to know this whole area in here of 10 degrees. So we're basically going to do the same way, except we're dealing with area here. So I'm going to figure out the area of the circle first. If the radius is 2, the area is going to be 4 pi, because 2 squared is 4 pi. Don't get confused, I'm not using the diameter there. It's a coincidence that the diameter is the same as r squared. And then I am going to just figure out what fraction of the circle that is. So the area of the sector, I'm going to do a sub s, is equal to 10 over 360 times 4 pi. And then I've just got, because once again, I want this as a reduced fraction, I'm just going to see, well, what can I reduce this by? This is easy. I got 10 over 360, so the zeros will cancel out. It's 1 over 36. And then 4 and 36, they're both divisible by 4. That's going to be 1, and that's 9. So that's just 1/9 pi if I'm writing it in the computer program here, or if I was writing this on a test, I'd do 1/9 pi, or once again, I could do pi over 9 would be the same thing. Next one, kind of the same thing, except these are actually easier because I'm writing these in decimal form. So I don't have to mess with this business of I'm going to slide this up some. I don't have to mess with this business of reducing this, so that actually will save me some time. So same kind of thing, I've got a circle here, it's got a radius of 10, obviously none of these are to scale. It's ZB, and BZD is 55, about that big. That's 55 degrees. And once again, I'm looking for arc length. So I'm going to find the circumference first. Circumference is 20 times 3.14, because I'm going to get an approximate answer. And then because I want to just figure out that fraction of it, I'm not going to multiply that out yet. I'm going to pull my calculator out in a minute. I know that the length of BD is equal to 55 over 360 times 20 times 3.14. And I just take out my calculator and I do 55 divided by 360 times 20 times 3.14, and the answer is 9.59. And this makes sense because this is roughly 60 and this is roughly 1/6 of the pi. So 60 over 360 would be 1/6, and that's roughly 60. So 9.59 seems like a reasonable answer. So 9.59. And then finally, same problem as up here with area, except once again I'm doing it as a decimal. So I've got a circle K that has a diameter of 12, it's KE, and then we've got a sector that is 145 degrees, so it's a fairly large sector, and that's EKF, so this is 145, and I want to know kind of what, I'm going to color this in a bit, I want to know the area of that whole piece. So same thing, area equals 12 times 12 times 3.14. I would suggest you actually do the 12 times 12 first. Depending on your calculator, you can accidentally do 3.14 times 12 and then accidentally square the 3.14 as well. So if you do the pi at the end, it'll make things safer depending on how familiar you are with your calculator and what kind of orders of operations it carries out. So finally, that's the area of the whole circle. So the area of the sector is just that fraction apart. So that's going to be 145 over 360 times, I'm just going to say whatever my area was up here. And then I'm going to plug that all in the calculator. And so 145 divided by 360 times 12 times 12 times 3.14 comes out to a whopping 182.12. So 182.12. And that's all for now. Thanks.